factors of production are input. So there is a basic distinction between output and value. As I mentioned to you, the factor productivity are easy to measure. That value added divided by capital, value added divided by labor. These are all the factor productivity. Okay. Maximizing. Okay. Or you can also take output divided by capital, output divided by labor. These would essentially give you some reflection on the factor productivity. And then I mentioned to you that TFPG is conceptualized as technological progress or technological regress plus the change in technical efficiency. dTE upon dt means the change in technical efficiency over time. dy by dx to use that. So that is dTE upon dt, that is the change in technical efficiency over time. So if technological progress becomes negative, then you know it is technological regress. But we expect that technological progress will happen over time, so that we will be able to enrich ourselves. Now, how do you estimate? One quite easiest method is called growth accounting technique. Growth accounting technique, you take the rate of growth in value added minus, within bracket, you have the weighted combination of the rate of growth in capital and rate of growth in labor. So if you have a series in capital, if you have a series in labor, you can easily calculate the rate of growth in capital and rate of growth in labor. But remember, when you are calculating the rate of growth in capital, it has to be in constant prices. Otherwise, inflation is happening. So every year you have inflated values, so you will have to net out the effect of prices. So you convert the series in constant prices and then you calculate the rate of growth in capital. Similarly, when you are considering the rate of growth in value added, value added should be considered in constant prices. You should not take in current prices. Now the question is, what is this W1 and W2? These are the two unknown things. So if the capital series is given, labor series is given, value added series is given. So you will consider up to these three series, but what is W1 and W2? We will come to that. Then here you have, if you are considering output, then what you do? You consider rate of growth in output in constant prices minus the weighted average of all the inputs. Rate of growth in capital, rate of growth in labor, rate of growth in material, rate of growth in energy. And what are the weights? A1, A2, A3, A4. So the whole question is that how do you work out those weights? So that is the crucial part. Then you are also assuming there is constant returns to scale, because you don't want to give the benefit to an enterprise which may be in its initial stage and therefore it is experiencing increasing returns to scale, or an industry which is very old and it has been surviving in the market for a very long time and therefore it is experiencing decreasing returns to scale. No, we don't want to consider that. We will be considering only the assumption that there is constant returns to scale. So that on an average, you are able to see what is the difference between value added growth and the input for these industries. So this is a crucial assumption. Now in growth accounting technique, what you do, as I mentioned, that this is the formula. So you will have to work out the W1 and W2. So W1 and W2, the weights must always add up to 1 in such calculations. So if I know W1, automatically W2 is known to me. So how do I calculate W1? W1 is relatively difficult to calculate. Okay, because W1 is the share associated with rate of growth of capital. W2 is relatively easy, which is the weight associated with the rate of growth labor. So how do you do it? You take the wage rate, multiply wage rate in constant prices, wage rate, multiplied by the total number of laborers, divided by value added. So that gives you the weight. So what you are assuming, that labor price per unit into the total amount of labor plus capital price per unit into the total volume of capital should be equal to value added. So if you divide both sides by value added, on the right hand side you get 1, on the left hand side you have the share of labor and share of capital. So share of labor is easy to calculate. Once you do that, then automatically 1 minus share of labor will be equal to the share of capital. So you do that. But here there is one problem. You have a series, let us say starting from 1980 to 2024, value added capital labor. The share of labor and share of capital is changing over time. It is not fixed. So how much labor share for which year should be taken is a key question. Now some methods would say that okay, in the initial year, in the first year, what was the share of labor? You consider that. So suppose labor share was 40%. So then you will say 60% share is for capital. So 0.4, 0.6. W1 is W2 is 0.4, W1 is 0.6. But some people say that no, initial year is very old, 1980. After that, lot of changes have taken place. The share of labor and capital have changed drastically. So maybe you should take the average of W1 and W2 or whatever. I mean, there are a lot of debates on that which share one should be considered. Anyway. So the growth accounting technique, as I will show you in the Excel sheet, is relatively easy to calculate.
So we are, as we are fixing the price constant, then it means we are taking the inflation out of the picture.
Yeah.
So how can we take the inflation out of the picture? How can we fix the constant price?
You can work out in this manner. You can look at the price index. We have the wholesale price index, and also we have consumer price index. Maybe the wholesale price index would be more appropriate in this context. So you can look at the movement of the prices. Okay. So suppose in 1980, suppose it was 100, then it went up to 120, 150, 200. Likewise, you have the series. So you take that series and deflate the figures for value added. Suppose my income today is $100. Yesterday also it was, I mean one year before it was $100. It doesn't mean the value is same. If you adjust for inflation, 100 may become 90. So that means my actual income has declined. Or if my income is now, let us say 150. So you may say that even in real terms it has increased. It may not be 150, 100 after price adjustment, let's say it is 130. So that means there is a real increase. So from the price series, you can essentially deflate. So of course it is very important that how would you calculate the capital price series, how would you calculate the value added price series. It's a very, very important question. Because capital is not a homogeneous commodity. You have several inputs in the domain of capital. You have land, you have machinery, you have many things. So you can combine those prices. You take the land price, you take the building price, you take the material, you take machine price, etc., and then you try to combine them and form a general price. Okay, for capital, and then use that series to deflate the value of capital. It's a simple rule of thumb. Suppose you say today's 120 is actually equivalent to 100 of the initial year. So suppose in terms of prices. So suppose today you are using 5 million rupees of capital. So 5 million multiplied by 100 divided by 120. So it will be reduced. So that is the price of, I mean, today's price in the initial year's price. Current price is being converted to constant price. So under the assumption of constant returns to scale and then apply growth accounting. So there is another important technique because W1 and W2 calculation is little difficult. That which specific share you would consider, whether the share in the base year or share in the terminal year or share of the averages, which one is to be considered? Since there is some confusion, people say you follow the semi-econometric technique. In semi-econometric technique, what happens? You take the value added series in constant prices, capital series in constant prices, labor is number of hours or number of human beings. And then you regress. Okay. So when you regress log of value added on log of capital and log of labor, these two coefficients will be estimated. So these two, and when you are imposing the constant returns to scale assumption, then automatically W1 plus W2 will be equal to 1. So the regression should not be an unrestricted regression. The regression should be a restricted regression. That when you are regressing log of value added and log of capital and log of labor, you give a command that coefficient of capital and coefficient of labor should be equal to 1. So once you put that restriction, you will get the W1 and W2. Okay. So once you got that, then you calculate the rate of growth of value added minus W1 is known to you, rate of growth of capital is known to you, W2 is also known to you, and rate of growth of labor is also known to you. So then you can work out the residual. Okay. So the difference between growth accounting technique and the semi-econometric technique is important. In the growth accounting technique, you are completely ignoring the fact that base year or middle year or the terminal year shares are I mean, these share, which specific share will have to be considered is not really known. Okay. In the growth accounting technique, you have been confused about that. That whether to take the base year shares or the terminal year shares or the middle level shares, you do know. Whereas in the semi-econometric technique, you are able to identify that which specific weights should be considered. Because on an average, the coefficients of capital and the coefficient of labor will be given. And those are the shares of capital. So that is why some people prefer semi-econometric technique over the growth accounting technique. Because of this confusion that W1 and W2 need to be worked out. Then comes pure econometric technique. In pure econometric technique, what happens? You regress log of value added on log of capital, log of labor, and you have an additional term. Additional term is your trend, time trend. Time trend, how do you fix the values? 1, 2, 3, 4, 5, 6, that way. Your year, let us say, starts from 1980, goes up to 2024. So if it is a continuous time series, you just assign 1, 2, 3, 4, etc. Annually. So you are regressing this log of value added on log of capital, log of labor, and you have a time trend that is T. And that coefficient of T would essentially give you the rate of total factor productivity. Of course, you will have to again impose a restriction that there is constant returns to scale. That is, share of capital and share of labor are the coefficients of log of capital and the coefficient of log of labor must add up to that. So that means you are ruling out the possibility of increasing or decreasing returns to scale. There is only constant returns to scale. And you are not making any assumption that whether W1 will pertain to the base year or middle level year or terminal year. On an average, what would be the share? The data will speak for itself. You are not imposing any restriction. So from that point of view, every method has some advantages and disadvantages. And then this is what is called as the residual. Earlier in growth accounting, what was happening? You took these terms to this side and rate of growth in value added minus the weighted share of capital growth and labor growth. Okay. Now what you are doing, you have incorporated this term T. So that coefficient of T will essentially give you the rate of growth. Suppose the coefficient of T is 0.025. Multiplied by 100, how much? 2.5. So 2.5 is the rate of growth in total factor productivity. Suppose it is minus 0.001. What does it mean? That means multiplied by 100, that becomes minus 0.1, isn't it? So total factor productivity growth is declining at a pace of minus 0.1. So not necessarily, as I was discussing in the first lecture, not necessarily total factor productivity growth will always be positive. It can be zero, it can be negative, it can be anything. Minus 0.015 multiply it by 100, minus 1.5. So total factor productivity's growth is actually declining at minus 1.5% base. So this is what I mean. G into 100 is the TFPG in percentage terms. But here you must remember that this kind of an exercise can be done only when you have pure time series data. Time series data in the sense, for a given industry, let us say chemical goods industry, a particular firm is manufacturing chemical goods. So you have the information starting from 1980 to 2024, and then you calculate these values. The problem arises when you have a cross section of firms. In a given industry, suppose iron and steel industry, there are some public sector units, there are some private sector units. So you want to compare. You in the public sector you have, say, Steel Authority of India, and then in the private sector you have Tata as the giant company. So you would like to compare that whether public sector is doing well or private sector is doing well. Similarly, in certain your machine tools, you have a large number of firms. So who is doing better compared to the other? That is a very important question. So that in a cross section, you cannot estimate TFPG. TFPG is a flow concept. It can be estimated only over time. But when you are considering the cross sectional information, you can essentially estimate the relative performance, the relative efficiency, whether you are utilizing the resources to the best possible extent or I am utilizing the resources to the best possible extent. What is our relative efficiency? Whether it is yours is 80% and mine is 70%. So that is what can be calculated through technical efficiency. But here, when we are considering these three methods I mentioned to you, one is pure growth accounting technique, another is your semi-econometric technique, and the third is your pure econometric technique. So in these three estimates, you can essentially work out the total factor productivity growth. And let me tell you that not necessarily these three methods will give you the same results. The methodological differences will have a significant impact on the estimation. Because TFPG is very, very sensitive to two things. One is methodology, and the other is the price that you choose to convert them into constant prices. To convert the series into constant prices. Suppose for capital, I am taking the machine tool price to deflate the capital series. You are considering a weighted average of machine tools, plants, buildings, land, etc. So your price index and my price index are very different. So when we are converting the capital series by two different prices, the magnitudes will be different. And then when we are estimating the TFPG, the results will be very, very different. Okay. So it is very, very sensitive to the selection of prices and the kind of function or the kind of methodology that you choose. Usually you will find that the growth accounting estimates are very different from the econometric methods. So it is up to the researcher. Then you will have to decide which one you want to use. Of course, growth accounting will have certain advantages, I will tell you later, compared to the econometric method. But econometric method might give you a better estimate compared to, more realistic estimate compared to the growth accounting estimate. Okay, so let me tell you here. How would you advantage of growth accounting technique over the econometric or econometric technique? Here in the growth accounting technique, what is happening? You are able to do the analysis, the estimates for each year. Between 1981 and 1980, what was the growth rate of value added? What was the growth rate of capital? What was the growth rate of labor? And you have the share of labor and share of capital. So then you estimate. Then between 81 and 82, What was the growth rate in value added? What was the growth rate in capital? What was the growth rate in labor? And you have their weights. So again, you get a figure. Okay. So for each year over its preceding year, you are able to get a total factor productivity. So suppose between 81 and 80, it is 2.5. Between 82 and 81, it is 1.5. Between 83 and 82, it is minus 1.1. So likewise, you will be able to see the rate of growth in total factor productivity over each year. And now you can essentially plot that. And you can see that how the growth rate in total factor productivity growth is behaving. Whether it is following an increasing trend, decreasing trend, or a highly fluctuating trend, all that can be decified. So that's a great advantage of having total factor productivity growth estimates for each year. Whereas if you are applying the econometric technique, you will be able to get only one figure for a particular period. Because you have the average rate of growth of value added between 1980 to 2020. You have the average rate of growth in capital over this period and of labor over this period. And similarly, you have the average labor share and average capital share as estimated from the econometric. So, if someone is asking you, I want the figures for each year, then you will not be able to work it out through pure econometric method. You will just give present one figure that during this period, 80 to 2024, the growth rate has been, let's say, total factor productivity growth rate has been 1.1 or something. However, you can divide the entire period into certain sub-periods. So 1980 to, let us say, you take 1990 as your deregulated regime or something like that. Deregulated regime is actually from 1984 onwards. So anyway, you can take the 80s, then 91 to, let's say, first phase of reforms. Then after 2005 or 6, you can take another phase of reform. Likewise, you can divide the entire period. Then for each sub-period, you can calculate the total factor productivity growth, even if you are following the pure time series method, pure econometric method. Okay. And then the question is, if you have the growth accounting technique which estimates total factor productivity growth for each year, how would you answer the question, what has been the average rate of growth in total factor productivity for this year? If you are following an econometric method, you have the average rate of growth. But if you are following the growth accounting technique, you have individual year-to-year rate. And you cannot average the year-to-year growth rates. Suppose I say in last 1 year, growth rate was 1%, then it was 1.1%, then it was 2%, then it was 3%. If you add them and take average, that is wrong. Because exponentially you will find that in such methodology, only the last figure and the first figure will emerge. All in between figures will be dropped out. So it is wrong to take any average of the growth rates. You should rather follow the pure econometric method to get the average growth rate, or what you do the growth accounting technique and then you index the productivity. How do you index? So you say that the first year productivity is, let us say, 100. And now you, from the growth accounting technique, you know the growth rates over years. Between 81 and 80, let us say it is 1.1%. So in 1980 it was 100, index is 100. 100 will become 101.1. Likewise, you prepare an index of total factor productivity, not growth. Okay, index of total factor productivity. And now you replace log of productivity index on time frame. This coefficient will give you the average rate of total factor productivity growth over this period. So I would say that growth accounting technique has both the advantages. It can give you year-to-year growth rates, and from that you can also calculate the overall average rate of growth in productivity. Whereas the pure econometric technique will give you only the average total factor productivity growth rate over a period, but it cannot give you the year-to-year growth rate. So pure econometric technique may be more appropriate, but it is not able to give you the year-to-year fluctuations and the average both. Whereas your growth accounting technique can give you both. Okay. Now we come to pure cross-sectional study. In pure cross-sectional study, what you are imagining that your technology is given. Technology is given, so there cannot be any change in technology. Because technological progress is an intertemporal concept. You will work for 6 months, then you will be able to realize that there is a change in technology. Okay. So unless you sort of pursue your innovation, you will not be able to experience the technological progress. So in cross-sectional study, we are saying there is no technological progress. Technological progress has come, is given. So technology is given, and then you are trying to see that which form or which industry is using that technology to what extent. Your farm is using maybe 70%, my farm is using 60%. That is what we should be able to estimate. And that is also a very important exercise. Like there are some industries where you will find most of the farms are much, much below the frontier. That means they are not able to exploit the technology at all. And then there are some farms where you have very good leaders, where performance is almost 90%, 95%, and then there are some farms which are performing at a very moderate level. Then you will try to see that why one is doing so well and why another is doing so poor. You will be able to then identify. So it is very important to estimate the technical efficiency. So how do you do that? So here we use the concept of stochastic frontier function framework. Some people use linear programming, that is called data envelopment analysis, DEA. But here what I have proposed is called as your econometric approach, that is stochastic frontier function approach. In stochastic frontier function approach, you are imagining that there are two types of errors. One error is basically represents the random error. So whenever you are regressing one variable on certain other variables, you will never be able to explain 100%. So there would be some discrepancy, and that discrepancy is captured through certain error, and that error follows a normal distribution. But when you are subscribing to this particular method of stochastic frontier function framework, there you will imagine that there is an additional error term. That additional error term, how it is emerging, we will pose that question later, but it exists. And that is the reason why your efficiency is 70% and my efficiency is 60%. So that is what we are denoting in terms of U. So this V is nothing but V is the random error, which will always be present in any econometric exercise. But this U is basically representing that why your efficiency is 70% and mine is 60%. So our objective will be to estimate this particular, and then we can index them. The best performer can be taken as 100, and then the worst. Accordingly, the other performers can be indexed. So if your performance is, let us say, 90%, then accordingly I can work out the performance of the other firms. So, but here, one important point is that when you estimate these equations, this will have stata. Does it have stata? No, it doesn't have. I have stata. So okay. Oh, so what happens? Our basic purpose is to estimate this U. So when you have to estimate this U, you will have to subscribe certain econometric properties to that distribution, because V follows a normal distribution. Okay. That is known. A random error follows a normal distribution. But U is only one-sided distribution. That means your performance of we are trying to estimate the performance of each other. Our performance cannot be more than 100%. 100% is the cap. So how much below we are is the important question. So that means that you will follow only one-sided distribution. You cannot be greater than 100. You will be always less than 100. So we say that in technical term, we say that you would follow a positive distribution, one-sided distribution. So one-sided distribution, that means we will have to tell the computer, each package will have certain alternative methods. So Stata will have all these optional methods, exponential, gamma, half normal, etc. These are all positive distributions. So you will have to click on that to say whether it follows an exponential function or a gamma function, a gamma distribution or a half distribution. And then accordingly you will estimate the. The problem is, if you are saying u follows an half normal distribution and I say u follows an exponential distribution, then the efficiency that you have calculated and the efficiency that I have calculated can be different. Now, the Kalirajan had a very interesting paper. So he was trying to do the estimation for different farmers. And then he was trying to figure out that which farms are more efficient compared to the other ones. And his finding was very interesting. He could show that the efficiency indices are not very sensitive to the selection of the distribution, which is a consolation for us. That means whether you are choosing half normal and I am choosing exponential, our relative ranking will remain the same. Maybe our magnitudes are different. One would say you are 90% efficient, I am 80% efficient. When I am using another distribution, it would show you are 91% efficient and I am maybe 79% efficient. Ranking is same. You are still the top. I am below that. Okay. So the Kalirajan pointed out that irrespective of whichever distribution you choose, there is a robustness in the efficiency estimates. So from that point of view, one can select some of these properties and you can go ahead. You can, in fact, if you have a data set, you can do the experiments also. Once you choose exponential and work out the efficiency index. Next time you introduce the half normal distribution and work out the efficiency index and try to compare them whether the relative efficiency indices are different or same. Then the most important thing is your panel data. Panel data means, let's say there are 100 industries. For each industry, you have 10 years of data. Okay. So 100 into 10, 1000 observations you have. So you have two dimensions. Over time, how industry, you were 90% efficient, I was 80% efficient. In another year, you are 90% efficient, but I am 75% efficient. That means the difference between you and me is changing. So all that can be captured through panel, if you have panel. So it will tell us the technical efficiency at a given point in time. It will also estimate the total factor productivity of a given industry over a period of time. It will also tell us the difference in technical efficiency between two firms over a period of time. So three things can be captured. So panel data estimation is the most appropriate one, though this is the most cumbersome. How will you do it? Okay. Basically, in panel data estimation, what you do, the growth accounting and your econometric methods I have explained to you. In panel data, what you try to do, you first try to regress the log of output on log of various inputs for each of the industries over a period of time. That is why you can see two subscripts. Okay, I, J, and then T is also there. Okay. So let us say I is your different form. Okay. J represents different inputs, capital, labor, material, energy. Okay. I represents different forms, and T represents time dimension. Okay. So for each form you have interpreted data. And then you are imagining that this aggregate error term is basically composed of two error terms. V, the normal distribution, and U, which follows a one-sided distribution. But the interesting point in panel data that you don't have to specify a certain distributional property to U. In cross section, what happened? You have to believe that either it follows a half normal distribution, or exponential distribution, or gamma distribution. Okay, the positive distributions. But here, when you are dealing with panel data, you don't have to subscribe to that kind of an assumption. It is all in relative terms. You will estimate this equation, and then you will get the error terms. Okay. Now, this error terms, estimated value, like when you are regressing, the difference between observed value and the estimated value is the error term. So you get the error terms. Now, this error term will be regressed on t and t square. So, which would mean that the change in technical efficiency can be found. If I say if I say that this error term is a function of t only, it would mean that over time it is either increasing or decreasing, which is a very strong assumption. That should not be entertained. What do you presume? That it may rise and fall, it may fall and then rise. You allow the data to speak. You don't impose any kind of strong assumption. So that is why you take the error term and then you try to regress it on t and t square. So that will essentially, based on that, you will figure out which form is the most efficient one. And when you are doing this exercise, what you will do, you will consider each industry or each firm separately. Suppose we subscribe to the earlier example, there are 100 industries, and for each industry you have 10 years of data. So for each industry, you do this exercise. This equation will be estimated for all industries, all of observations, that is 1000 observations. Then you take each industry separately. 100 industries, so 100 times you do this equation. But there are commands, in one go you can do 100 equations. So one equation will represent one industry. So for one industry you have 10 years data. So error will be regressed on t and t square for one industry. For second industry, again you regress error on t and t square. Okay. Likewise. And then you will be able to calculate the technical efficiency and the change in technical efficiency as well. Okay. So this is, and this is considered to be, though it is little difficult, but this is considered to be the most appropriate one as far as your estimation of total factor productivity growth is concerned. And the interesting point here is that you are able to decompose the total factor productivity growth in terms of technological progress and change in technical efficiency. The coefficient of t in this equation, when you have done your regression based on 1000 observations, will give you the technological progress. Your only strong assumption is that you are believing that technological progress is same for all the industries, which is fine. In a globalized economy, once the knowledge is penetrated into the economy, it can be disseminated soon. So not necessarily your knowledge base and my knowledge base will be different. So everyone would be able to access that information. So technology can be same for everyone. So technological progress coefficient would be uniform for all the industries, or in a given industry for all the firms. Okay. So this coefficient of t multiplied by 100 will give you the rate of technological progress. So suppose it is 0.025 multiplied by 100, it will be 2.5. So 2.5 is the technological progress. Suppose it is negative, it would mean there is technological regress. So at what pace the technological regression has taken place, that can be identified. And then when you are doing these regressions, that where the error is regressed on for each industry or each firm separately, when you are doing it, there you will be able to identify the efficiency for each industry separately. Then you pull them together. Okay. So you have done for first industry, you have done for 10 years. For For second industry, you have done for 10 years, and you put them in one column. So now you have these estimates of technical efficiency. In that column, you try to see which one is the best performer. You take 100 for that, and then for the rest, you accordingly do index. And now from that, you can also measure the change in technical efficiency over time, how a firm is behaving, whether its technical efficiency is remaining constant or it is changing. That can also be done. So that is why it is able to decompose the total factor productivity growth in terms of technological progress as well as change in technical efficiency. Whereas if you are using the time series method, then you will have only total factor productivity as a combined effect of technological progress and change in technical efficiency. You cannot decompose them. On the other hand, if you have purely cross-sectional data, then you have only technical efficiency of firms across firms given the technology. You cannot estimate anything over time because it's only a cross-sectional data. So anyway, all the three methods are important and it can serve our purpose in different contexts. So as I was mentioning, estimation can be done for all firms in a given industry. You take a specific industry machine tool, take 200 firms, work out their technical efficiency, or for all industries in a given country. That is also possible for different groups of industries, or for a given industry or aggregate manufacturing across countries. That is also possible. Like we had used the UNIDO data to do the total factor productivity growth for different countries, developed countries, developing countries. Okay. Now, deflation of nominal series, the question which you were asking. That I told you that how to sort of deflate it, that arithmetical problem, that you take the current value, multiplied it by the base year index divided by the current year index. So that would give you the deflated series. Fine. But the question is whether you should consider a double deflation method or a single deflation method. So when some people use the output price series to deflate the value added. Because value added is defined as the contribution made by capital and labor. But in real world, it is very difficult to make a distinction between value added and output. Output is perceivable. You can understand, okay, this much output has been produced. So value added is not perceivable directly. You will have to calculate it. How will you do it? That is output value deflated, of course, minus the value of the material and energy. Then only residually you will know what is the contribution made by capital and labor. So it is a conceptual sort of idea. It's not exactly directly measurable. So therefore, you will have to deflate the value added. How would you deflate? Value added the price is not available anywhere. You will have output prices, you will have input prices. So some people take the output price series and deflate the value added series. But that is wrong. It's not wrong, I would say it has certain problems. In the sense, there is a strong assumption involved. It says that if you are considering the output price series to deflate the value added series, you are assuming that the material prices and the value added prices, they have moved at the same pace, which is not correct. Material prices might have moved in a different pace. So the double deflation method can be more appropriate. So what you do in double deflation method, you take the output series and you take the output price, deflate it. You take the materials for a given industry separately, take the material price, deflate the material quantities by the material price index, and then from the output series, deflated output series, you net out, deduct the deflated material series. Then you will get the deflated value added. This is what is called as double deflation method. So in double deflation method, you are deflating the output by output prices, deflating the inputs by input prices, other than that, deducting one from the other, and what you get is the deflated gross value. Whereas in single deflation method, you assume that output and material prices are moving in the same manner, and then you follow that. Then there is also considerable amount of research to determine the impact of TFPG on well-being. I mean, estimation of TFPG is one important point, and then in the second stage you can also work out the determinants of TFPG or determinants of technical efficiency. That why one firm is performing better than another firm, why one industry is performing better than another industry, or over time, what are the determinants of TFPG? All that can be done. Also, what is important that you can assess the impact of TFPG on certain other important indicators. If TFPG is improving, whether our well-being levels are also improving. If TFPG in a given industry is significantly high, whether the employees are also getting the higher remunerations, whether their wages and salaries are also improving significantly. Because after all, we would presume that if the performance of an industry goes up, then naturally it would have positive spillover effects on the well-being levels of the workers. So whether in terms of work conditions, in terms of wages and salaries, the performance is increasing or not, that one would like to figure out. Similarly, at the economy-wide level, if your total factor productivity growth is taking place at a very rapid pace, whether the standard of living of the population is increasing or not. In many developed countries, you would find that their TFPG growth rate was very high, and at the same time, people also benefited. In the developing countries, your TFPG growth is sluggish, and therefore your well-being levels are also not improving fast. So that is another line of research which has attracted a lot of attention. Then you would also like to see what is the ownership pattern, whether the public sector units are performing better or private sector units are performing better. Why public sector units are not able to compete with the private sector units? That can be one. Why Tata is doing much better than the units which will come under Steel Authority of India. So all these questions are very, very interesting. Like in pharmaceutical industries, you would find that the private sector units are performing much better than the public sector units. And the private sector units, why they are performing better? Because they are able to innovate to a large extent. Research and development expenditure in the private sector units in pharmaceutical industries is enormously large. Whereas the public sector units are not able to pursue innovation at that pace. But most of the incentives are going to the public sector units. Very sort of asymmetrical decision. So this is another class of interesting literature. Similarly, you can relate it to demographical studies and also your labor market studies. Regions where total factor productivity growth is very high are whether experiencing higher rates of population movement, migration. We say that people are quite well informed. I mean, my uncle has migrated to Delhi, so I contacted him, I figured out the information, and then I also migrated. So they say that information flow is very significant and migration decision is taken very rationally. So if that is true, then we need to figure out whether migrants actually move to the regions where the total factor productivity growth is high. If that is true, then we should be able to see that the wages in a region where total factor productivity growth is much higher than the wages in the region where it is the total factor productivity growth is higher. So these kind of studies have also been undertaken to a very, very large extent. Okay. And then there is another class of literature which says that why the firms are not able to pursue a lot of innovation expenditure. That is because their TFPG performance is very poor. We say, yes, if innovation is high, TFPG will be high. But then you look at it from a different point of view. Only when I have surplus resources, when my TFPG is high, then only I will be able to spend. Right? So in the next round, what becomes important is your TFPG performance. So if TFPG performance of a country or farms is very poor, then naturally they will not be able to contribute to more research and innovation. So that is also another way of looking at it. Another issue is that how do you aggregate? Suppose you have estimated total factor productivity growth for steel industries, for chemical goods industries, for machine tools industries, for garment sector, etc. Now, how do you combine? That's a very important question. So there are many different methods. So one is your Domer aggregation. That I think is the simplest form of aggregating it. And then you can come up with one specific index that this is the total factor productivity growth for all industries for a given country. Okay. So with that, let me take you to some Excel exercises. And first I will do the growth accounting, which I can do in Excel. Then I will take one step. See, can you see? This is my value added, and this is my capital, and this is my labor. Whatever the units are, because we are not bothered about the units. Measured in labor is measured in terms of hours or in terms of number of workers, and capital is measured in terms of value of capital. Value added is measured in terms of again value. So let's say we have already deflated the figures. Deflation I have already explained to you. I'm not going to show you the deflation. So these are deflated figures. So what I do, I consider take log of all these variables. Log of value added, log of capital, log of labor. Great. So I am following the growth accounting technique here. In following the growth accounting technique, I need to have the labor share, that is the coefficient of labor growth. Then I would have the 1 minus that would give me the capital share. So to calculate the labor share, what do? I need wage rate. Okay. So wage rate is given. Okay. Then I am calculating labor share. That is wage into C into D. C is what? Labor, total amount of labor. D is what? D is the wage rate per person, per labor. Okay. So C into D divided by A. A is what? Value added. Right. So this is my labor share. C into D divided by A. Once I know labor share, I can work out capital share. 1 minus labor share is capital share. Right? 1 minus H. That is my capital share. Okay. Now I am coming to the rate of growth in value added. Rate of growth in value added, how do you compute? That is the log of value added, this one minus log of value added, this one, the previous period. So that will give me the growth rate in value added. Similarly, growth rate in capital, how am I doing? So F3 minus F2. F3 is what? F3 is log of capital. Log of capital in 1 year minus the log of capital in the previous year. So I get that. Similarly, I also calculate the rate of growth in labor. Log of labor in 1 year minus log of labor in the preceding year. Right. Now I am estimating TFPG. So TFPG is what? TFPG is the rate of growth in value added, that is J, minus H3 into L3 minus I3 into K3. Within bracket, you write plus, or if you open the bracket, it will become minus. So, rate of growth in value added minus the weighted rate of growth in capital minus the weighted rate of growth in labor. Right. So, J3 is rate of growth in value added, H3 into L3 is the weighted rate of growth in labor, I3 into K3 is the weighted rate of growth of capital. So this gives me the TFPG. So in 1 year it was 1.15%. I have multiplied it by 100. Okay. Then in another year it is 10.76, 7.73, like this. You are able to see, right? It's very, very different. Now the question is, I can index it. So suppose first year was 100. So 100 has become 101.15. Then it has become 90.26 because minus 10 point was the decline. Then it becomes 97.24. So this is how I am able to get the index of total factor productivity, right, for each year. Sorry, index of total factor productivity. This total factor productivity growth is a dynamic concept. Total factor productivity is a static concept at a given point in time. I got the index. So now if someone would ask me that what is the average rate of total factor productivity growth in this entire period, then if I am taking an average of this, it is wrong. Right? That is what I was trying to tell you. Usually people don't understand and then take the average of the growth rates. Average of the growth rates is a wrong concept. You will have to estimate the index first and then regress the index on T. So log of index. Okay, so this is my index of total factor productivity. You take log of this. Okay, then regress that total factor productivity, log of total factor productivity index on time trend. That will give you the average total factor productivity. Of course, multiplied by 100, that will give you in percentage terms. Is that okay? So this is the summary of your growth accounting technique, where you are able to estimate the total factor productivity growth over each year compared to the preceding year, and then you will also be able to estimate the total factor productivity growth for average total factor productivity growth for the entire period. That is possible from this. Now, no, you can. Suppose I have these figures. Log of value added, log of capital, log of labor. These observations pertain to different forms in a given industry. Suppose it is machine tools industry. So I have almost 19 forms. So for each form, my value added figure, capital figure, and labor is given. So I'm assuming technology is given to me. Now, given the technology, which form is utilizing that technology to what extent? And based on that, I'm working out the efficiency. So I will be assuming that there are two types of errors. That one is V, which follows a normal distribution, and then there is U, which follows a one-sided distribution. So what I do, I take the data, to stator. I'm following the shortcut, just copy paste. Right? So my data is come in stator. Now I will have to apply that stochastic frontier function framework. So I go to statistics, and then what I do is frontier models. Frontier models would mean that there is a frontier. For each level of input is the maximum at another level of output. So it is asking me what is my dependent variable. Log value added is my dependent variable. Log of capital and labor are my independent variables. Okay. And then it is giving me these options: half normal distribution, exponential distribution, and truncated normal distribution. It doesn't have gamma distribution. So these are all positive distributions. So by default, it has chosen half normal distribution. Okay. So I say, okay, this is my frontier estimation. Now I am interested in the technical efficiency index. So that means I am interested in the U values. One is V, another is U. U represents my efficiency or inefficiency. 1 minus efficiency is inefficiency. So I'm interested in U values. So here what I will do, I will go to the post estimation menu. Okay. In post estimation menu, I say I need predictions. This is predictions and their standard is as technical efficiency, etc. Okay. So I say this. Then it's asking me the variable name. So let's say tech F. Tech F is my variable. Minus the log of technical efficiency via this method. What I will do, I will go to the data editor. See, this column is the technical efficiency. Okay. I am not interested in V because V is a random error. I am interested in U. To what extent one is below the frontier. So first I did the regression, then I went to the post estimation menu. There I clicked on the technical efficiency and I got it asked me for a very new variable's name. I gave tech F and then it has been mounted in my data editor. Now I will examine within this series which one has the maximum value. Unfortunately, they are most of them are in the same range, right? By and large, very little difference, marginal difference. Anyway, you figure out which one is the maximum. You level it for 100. So suppose what is it? I think 0.00328 no 99. This is the maximum. Okay. So I will say this is my 100. If this is 100, then this will be how much? If this is 100, I can accordingly figure out the other estimates. So the 0.00332879 will become how much? Less than 100, obviously. So I can essentially work out each of them. Then you will say that how many farms are actually efficient and how much are inefficient, etc. And what is the level of inefficiency. In this exercise, they are almost equally efficient. Okay. So if I say this is 100, then the other one will be slightly below 100. So by and large, they would lie between 90 to 100 or so. But there can be cases where you have efficiency and inefficiency levels can be very different across farms or across industries. So this would serve this purpose of at a given point in time, given the technology, to what extent each farm or each industry is utilizing the level of technology and is able to experience the efficiency. Okay. Now this concept has also been, and now so I have shown you the growth accounting technique over in time series data. This is cross-sectional technical efficiency estimation. You can also do the growth accounting technique. So I don't have a T component. Anyway, I can mount a T component. T is what I will do, regress, log of value added, log of factor, log of labor, and T. This is pure economic. Okay. What is the coefficient of T? 0.74. So 0.74 into 100. How much it will be? Huge. This shows there is a huge total value. Anyway, this is a fictitious data set, so it is not the actual data. Otherwise, in reality, it is not possible to have such high rate of total factor. So this is how you can essentially do it. Okay. So this is your pure econometric method. But then this would indicate that on an average over this period, what has been the total factor. You will not be able to estimate it for different years separately, unless you are following the growth activity. So then, let me do a small thing for you. That is, this application of efficiency analysis in various other areas. So, you can apply this technique given the technology or given this maximum attainable level of output or value added, what is the efficiency of each firm or each industry, etc. That you can do for the manufacturing sector, you can also do for the banking sector. Many studies have been done, particularly people with management background have been pursuing this sort of research in the banking sector, that which bank is performing better. And then the next question will be that why this bank is performing better than the other bank. In what way it has a relative advantage? Is it because it is located in the very large metropolitan cities with many number of branches, or it has certain other avenues, certain other advantages? Why so? That is another important line of research. Then people have also used this technique, that stochastic frontier function technique, in the education sector. That you have the potential infrastructure. Now, given this infrastructure, to what extent it is being utilized? Whether we are utilizing the educational infrastructure optimally or suboptimally. Suppose you say you have created a school with very good physical infrastructure, with very good instructors, with very good amenities and all equipment, smart boards, etc. Now the question is whether the performance has accordingly improved or not. You may provide all kinds of facilities, but performance may not improve significantly. Then you would pose the question that why? What is the efficiency, the determinant of the efficiency? Maybe it depends on these amenities, but something more than that. So that is the education sector. Similarly, in the health sector. So when we say that health infrastructure is poor, so the question is if we will be able to augment the health infrastructure, will it be utilized optimally? In the rural areas, there is a debate that when you provide certain health infrastructure services, people don't utilize it. Particularly when it comes to gynecological illnesses and other related illnesses. People have certain taboos and women wouldn't like to utilize those services. So then the government would say that it is a wastage of money. Why should we then provide this kind of health infrastructure? You can get into more debatable questions. Suppose there is a very high mortality rate in a country. Could be because accident rates are tremendous, or could be because the infants are dying because they do not have enough maternal and child health care. So now as a government, you will have to decide which one you should pursue. Reduce more number of accidents or reduce the infant mortality rate. If you provide more infrastructural facilities for women and child health care and they are not being utilized, then your infant mortality rate will not decline. On the other hand, if you create more roads, widen roads, etc., then your number of accidents may come down and your mortality rate may come down. So you have very difficult policy choices at times and ethical considerations also. You cannot, you can justify by creating more roads, but how would you justify the high infant mortality rate? So there are certain issues. So these sort of exercises will enable you to engage yourself in very interesting policy making exercises. And then once you decide that no, infant mortality rate should get the ban over the road accidents, then the question is how would you motivate women and children to avail of these services? That the social, cultural practices, etc. All those questions we have to deal with. Okay. Then I had also used in my joint work with my supervisor, Edwin Mills, on population pressure index. That usually people say, the demographers say, that see the large cities have too much of population and therefore the large cities are overcrowded. We said no, that's not true. Large cities are having higher population numbers precisely because they have a lot of activities. Therefore, they are able to hold those many number of people in that space. So now they have agglomeration benefits. So therefore, more farms are trying to locate here. More individuals are migrating to these places. So large cities are not necessarily the ones which are characterized by high population pressure. So we try to estimate the population pressure index. So how did we do this? So we considered that stochastic frontier function framework, and we took population as a function of opportunities, infrastructure, etc. Then we worked out the maximum attainable level of population and the observed population. Then we could see that the observed population is higher than the population which can be held by the infrastructure and the opportunities. Here, the population pressure index is estimated just opposite to the technical efficiency. Technical efficiency is to what extent you are below the frontier. Here population pressure is population pressure is above the frontier. That means to what extent your actual population is above the population level, which can be explained in terms of the employment opportunities and the infrastructure. And we worked out the population pressure for each of the cities. Then in the next round, we were posing that what is the nature of these cities? Whether the large cities are characterized by high population pressure index or the cities and towns which are having very low population size. We could see that very small towns located in particularly in eastern UP and Bihar, they are the ones which are characterized by high population pressure. That means the population size could be less, but relative to the opportunities and infrastructural facilities, that population is much higher than what can be explained by these variables. So it completely refuted the argument of the demographers. We could show that using the stochastic frontier function, we could show that the population pressure index is actually high in the small towns, where the government had to provide a lot of benefits. Similarly, this approach has also been applied in the context of tax collection. The government has created the machinery, has encouraged certain activities, whether the tax revenue which is being collected from a particular region or from a particular state is up to the benchmark in relation to what has been invested. So one can pursue this kind of an exercise and one can work out which state government is optimally much better, more efficient compared to the other state governments. Thank you very much.
Thank you so much, sir, for the incredible, highly knowledgeable, insightful, and thought-provoking session. Now, I would like to request our Director, Dr. Professor Satyavan Baroda, to felicitate our expert with a memento.